MEI Statistics Minor Bivariate Data 2 Correlation Coefficients 2.4 using the product moment correlation coefficient as an effect size. Now there are limitations to a hypothesis test on the product moment correlation coefficient because it will only tell you two things. Either there is correlation or there isn't correlation. And in particular, if the sample size is very large, it can be very uninformative. So for instance, if we have a look at this data set, if you run it through and find the test statistic, R is equal to 0.184. Not that impressive a value really, quite close to 0. But if you run a hypothesis test, the two-tailed 5% critical value, because n is equal to 300 in this case, is actually 0.113. So 0.184 is quite a bit bigger than 0.113. So we would have to say that there is significant evidence of positive correlation. But I think we'd all agree that that positive correlation isn't particularly impressive. We can just see that from the scatter diagram. So often it's more useful to consider the size of the correlation rather than simply testing whether the population correlation is non-zero. So we use the phrase effect size in this context for the value of the product moment correlation coefficient. One example of this is Cohen's guidance. In social science, Cohen's guideline is very often used, where 0.1 is a small effect size, 0.3 is a medium effect size, 0.5 is a large effect size. For negative correlation, obviously these values are negated. You're not required to know these, although you may be asked to apply them, or similar. In the next video, we will be calculating Spearman's rank correlation coefficient.